Hello, this is Mr. Collier. Today we're looking at intersections with planes. So planes intersecting with planes and lines intersecting with planes. So the way to do it with two planes intersecting is if you look at their normal lines, right? Here's the normal lines right here. And we'll call this angle theta. And if I got this right triangle right here, this angle here, because this is theta, then this little angle here is going to be 90 minus theta. Okay, and this little right triangle. And this big right triangle, well, that means basically that this angle right here also has to be theta. Okay, so these angles are the same. Okay, the angle between the two planes is equal to the angle between the normals. So all you have to do is find the angle between the normals, and that's pretty easy with planes because we can see the normal right away. The normals are 1, 1, negative 2, and 1, 4, 1, right? So remember, to get the angle between two vectors, cosine theta equals the dot product of those divided by the product of their magnitudes. Okay, so we got, that will give us 3 over root 6 root 18, and then just do inverse cosine of that, and theta equals about 73.2 degrees. Okay, so that's all there is to it. It's pretty easy for intersections of planes. Now when a line intersects the plane, here's the normal to the plane. So this angle is 90 minus the angle we want. Okay, so we want this angle right here. We need to find this angle here using the normal and then do 90 minus that answer. Okay, so for a line, this is the direction, and for the plane we're going to use the normal. So we're going to do cosine theta equals the dot product of 332 5 negative 1 1 over the product of their magnitudes. Okay, that equals 7 over root 27 root 22. And when we get the angle, we get 73.3. But we want 90 minus the angle, so that gives us 16.7 degrees is the angle between those two, between the line and the plane. Okay, next, intersection of two planes. So this is actually finding not the angle, but the line of intersection between two planes. Okay, so if two planes intersect, then they intersect at a line. Okay, so these are obviously these aren't parallel because the normal vectors are different. So there's two ways to do this. One way is illustrated right here. Another way to do it is, now because this has got an x, y, and a z, somewhere along the way, the z value is going to be equal to 0, so we can set z equal to 0 at some point. And also, we probably want, also note that on this line, this line is on both planes, so it's perpendicular to both normal vectors. So we do the cross product of these two normal vectors, we get the direction vector of the line, right? So the cross product is 2 positive 1, negative 3. And to get a point on the line, we can just substitute in wherever z equals 0 and find the x and the y values of maybe this plane right here. Okay, so plug in z equals 0. We got well, actually we got to plug it into both. X plus y equals 4. 2x minus y equals 6. We'll add those together. We get 3x equals 10. X equals 10 thirds. Plug that in here, and we get y equals 2 thirds. Okay, so the equation would be the point 10 thirds, 2 thirds, 0, plus lambda or t or whatever the direction is going to be 2, 1, -3. Okay, the other way to do it involves just letting z equals t. We're going to, then find the vector equation like this, right? So let z equals t and x equals 4 minus y minus t, using this, right? Now we use this one right here. Y equals 2 times, and I'm substituting this in for x. Okay, y equals 8 minus 2y minus 2t plus t. I should probably use t here instead of lambda, because now I'm using t over here. Okay, so then we have, if you solve that, you get y equals 2/3 minus 1/3 t. And then we substitute back in here for x, 4 minus 2/3 minus 1/3 t minus t. And x equals 10/3 minus 2/3 t. So you got y and x solved, so you can write that in vector form now. R equals 10/3, 2/3, 0, plus t times, and you look at the numbers in front of t for this one, right? So that's -2/3, -1/3, and we said z equals t, so that's just going to be a 1 there, right? Now that's actually the same as this one here because they're scalar multiples, so you can multiply all these by 3 or -3 and get the exact same answer as we had here.